So let me start oh yes, when I was thinking how to start the lecture a couple of days ago, and I watched on television in Taiwan, and I saw this 5 minutes, actually more than 5 minutes report on the Rosenberg's activity on asteroid mining. I found it was a very timely, so I said, I think some of you might know this gentleman, and I think he's the head or something, his name is Linker, according to the Chinese translation. The 5 Ws, I think we have heard before, already that there are always 3 Ws to something, to things we want to do, which are why, what, and how, right? And then I add the 2 more, which is when and who. So that I am going to ask you one by one. Why? Why is that? Why we want to do that for asteroid mining? The part is for scientific curiosity, isn't it? Just by doing so, because that derived from our scientific research for one thing. So I assume that as we go along, so to say, take deeper and deeper into asteroids, we'll find more and more interesting things for science. So scientific exploration should be a very important driver. Second is it's a technical application. That means that now we have all these tools, hardwares, and then for space technology, we want to try them out. They're always novel challenges. So we just go, like climbing Himalaya, because it's there. People will say that, why do you climb Himalaya? People say because it's there. And then for asteroid belt, it's there, so we go there. And then of course, there's another driver is economic consideration, isn't it? I mean, we have been reading reports claiming that this asteroid and that asteroid would be trillion dollar, actually multiple $1 trillion worth. However, that depends on which asteroid you're talking about, how big they are. And so so there's one thing that we hope to learn from this forum. The next thing, of course, is the Earth defense. I think it's a very important driver for this activity, because after all, for the near Earth objects we want to get to, they also come close to us. So therefore, there's almost half and half. Those that come close to, always carry a certain danger of impact with the Earth, not immediately. But then when you do that, it also brings a lot of benefit to Earth defense from that point of view. Then what? So we are not in the position right away, to think about going to main belt. So basically, it would be near Earth asteroids, since their orbits are convenient to get to. But even convenient to get to, not everything, not every one of them is easily accessible. So we read the literatures, and there's a term called mission accessible near Earth objects, and initial is MANOS. Those are MANOS. That means that they have a very low, so to say, premium, in the energy, in velocity to take off and return. And there's a famous Shoemaker-Herring formula. You can see on the left-hand figure, and they look at some, that was in 1978, of course, and look at some near-Earth asteroids, and turns out the minimum delta V is above 5 or 6 kilometers per second. But more recently, people look at other, more near-Earth asteroids, and they find that some of them, you could reach them with 4 or 5 kilometers per second. Not many, but the peculiar thing with those MANOS, MANOS, is that they are small. So on the right-hand corner, you can see that those red squares are the so-called MANOS, and you really look at them. Look at the side, which is the horizontal coordinate, which is diameter. They're all sub-kilometer. Some of them even at the level of a 10-meter scale. So that means that the objects at this point in time seem that you can get there easily. They're small, and therefore you will have a discount in the economy benefit. But still, it's a good place to exercise. Another important thing is that those small asteroids, those are sub-kilometer or 100-meter or even less or 10-meter scale size objects, they spin very fast. So you can see that some of them even spin at a rate of about minute, 10 minutes or so, even less. The smaller they could spin faster. So therefore, that also, how to say that, have put a demand on the technology, and if you really want to go there, grab a piece of them. And we have now some information on the surface structure of small asteroids because of the mission to Itokawa, which is a half-kilometer big. And then we have Bennu, also about half-kilometer from NASA. And then we have Lugo, which is 1 kilometer big, and then that is from JAXA. And you can see that those asteroids, at least for Bennu and Lugo, they are filled with not with fine dust, but rather with those boulder, you might say that. On our hand, Itokawa, because it's the tulip structure, and then there's a region with how to say fine-grained areas. So therefore, the question to immediately come to you is that you want to go there, and how do you pick up those rocks and bring it back? And another immediate mission, of course, is the DART mission of NASA, which is going to Deimos, the Deimos, and then the hitting is a satellite, and they will also give some information, on those small size asteroids. So we have plenty to learn in the next few years. Then for a fast spinning small asteroid, we have another opportunity with the Chinese asteroid mission. We call going to 2016 HO3. I think that is the target, have been set and chosen. And then some of the detail you can find in the Nature paper by Zhang, Zhu, and Ding, I think published last year. In Chinese, it's interesting. It's called 震荡天星 because its orbit is kind of oscillating. This 2016 HO3, interestingly, is a baby brother of the moon because it's also moved around the Earth. So it's one of the first, it will be the first cislunar asteroid being visited by a spacecraft. And it's spinning very fast. I think that the estimate is about 30 minutes, 20 to 40 minutes. Maybe later on, Dr. Li Mingdao can tell us more about it. But then so that would also be a very, give us a key. They also bring a small pocket of material back to the Earth. This is a sample return mission. So you might call that this would be a prototype, of asteroid mining from this point of view. And don't forget that there's another very interesting asteroid from my point of view, which is Ceres. Ceres is the largest asteroid, and it is water rich. We know that it's also organic rich. So therefore, you can tell that eventually it could be a very good place to serve for the space resource purposes, because you could use there to extract mineral, extract material for refueling. So say if you are preparing to go far away, deep into the space, so you can consider to be like a gas station for interplanetary travels. So don't forget about that. If you're going to the main belt, I think that the Ceres would be a very important base for you, for processing things like that. Now, how I think that to prepare, we heard today in this morning about education, right, from the CUMT and the number of universities, including Colorado School of Mining. They're already starting a very mature and a program for master degree students. I think it's great. But then the other places, I think they are also doing initiating similar things. I think that the one part would be the robotic. I mean that when the time comes, you really first to do is you have to rely on robotic prospecting, right? So that go hand in hand with a number of things like machine learning, AI, because you're operating in a very far away and very difficult environment. And then the second thing is about the navigation propulsion. I feel that it depends on the maturity of several propulsion systems, like the electric propulsion. And of course, we have the DART mission. We know that the Disney Plus from JAXA is also trying out the electric propulsion. And then if China want to do that, I hope that they will also put investment in the electric propulsion, because for this kind of docking long-term orbital changes, you do need things like this. And then the nuclear propulsion, if you're ambitious, you're doing things big, and nuclear propulsion is a necessity. And then, of course, also solar cell. And solar cell, and my imagination is that if you have solar cell, you could turn the orbit around from those, how to say, from prograde into retrograde. So my wish that someday the solar cell can be used to chase after Comet Halley. Because Halley is in a retrograde orbit in 2062. So you still have maybe 30 years to work on that, 20 years to work on this solar cell. Now, after getting the material, extracting material, you want to bring it back, right? Even either processed and unprocessed. So this was touched upon this morning also. So there was transportation, from the asteroid belt, from near Earth targets. And I believe that Dr. Lee Mingdao will be telling us his research results on this aspect. And when? Now, when is a good question. I mean, everybody's guess, and we could have have a quiz, or you may call it survey. But if you look at the history of AI, there is chronology of AI, saying that how the idea of AI first come upon, and then of course very early in time, even in science fiction. But the real thing, people really put it into scientific term, academic environment, maybe 1955, and then you have computer. People think about really using computation technology to pursue, but it did not work out too well because the time was not right yet. Still, the 1980, I think there's some landmark event. We could call it the year of artificial intelligence. And it takes another 20 years. Then the AI start to take off, so to say, becoming a rapid progressing field. And if you use the same kind of pattern, for space resource mining, what would that be? I think for asteroid, you might call that. There's a book published by University of Arizona called "Resources of Near Earth Space," and some of you must have read it. I think the chief editor was John Lewis. And so 1993, you might call that the time that when he all started, so to say. And that was the time that the academic world consider this as a well-reasoned idea, not some crazy science fiction idea. And then the later one, then you have this planetary resources. If you know that very enthusiastic, in 2012, setting up a company, getting money even to do it. But then the progress is slow because you really had to get things together, right? And so in between, you see a number of companies set up. And then just a year or two ago, we have the Origin Space. So my guess is that if you take 2012 to be the the year of asteroid mining, as we have the year of AI, and you add the 20 years old to that, I would say maybe someday in 2032 you will have some landmark event. Maybe you get to an asteroid, really doing some prototype asteroid mining. So it turns out that this kind of chronology was similar to the estimate by Professor Zhang Kefei this morning, because he laid out a roadmap, and of course he took a very long-term view, and he could afford that. He talked about that the things really take off now, making a real industry in 2100, which is 80 years from now. But then he guessed that there will be a first asteroid mining exercise in 2030. So that was kind of close to what I had been thinking. But then who? Of course, we have many. We know that there are a number of number of countries, nations are interested in it, and spearheaded by Rosenberg. One can say that. But now Origin Space and the other companies and industries. But I think that I would because when this proposal for the forum on space resources was submitted to EC Beijing, the science committee reviewed it, and they like it, and they like it in particular the point that about the discussion on the legal aspect. So I feel that we would like very much a thorough discussion, at least an initiation of thorough discussion, in-depth discussion on this aspect, legal aspect. And my thinking is that since this resource, if we cannot allow one single private company, to grab everything, and leaving everyone in poverty. I mean, we have seen that recently, so we should not repeat that story 100 years from now. So I feel that one of the initiatives should be that this kind of resources, this kind of income, should belong to the whole world, not to just to one or few public company, one or few trillionaires. And so I think we should rely on the guidance of UN to do such a thing. Okay, I was just saying that there was the roadmap from Zhongguo Kangye Daxue. And you can see that taking about the second stage over here, and they will have the first time going to a target asteroid, right, in 2030 some here, and then they will start doing this first stage, like the Chinese would do, and fifth stage, and then they talk about building up a real industry, helping the society. Well, hopefully this is the case, but still in this along the way, we need to really keep track of the wealth sharing, resource sharing, because it doesn't belong to one single private company or two private companies. So at the end, so then I mentioned that at the beginning that we saw a television report, press news report on the Rosenberg's space dream, and he ended by saying that they would like to have the space mining to have a legal, legalized, so to say, the laws and so on. I think that should be our point of view also. So on behalf of EC Beijing, I welcome you, to participate, to come to the in-person meeting to be held in the near future. And thank you so much.